Welcome to this video on confidence intervals part 3, overview of the process of constructing a confidence interval. This video will answer the following questions. What are the four main parts of a confidence interval? What assumptions and conditions must be met to create a confidence interval for categorical or qualitative data? And lastly, what are the 5 steps of constructing a confidence interval? Let's begin. The 4 parts of a confidence interval are as follows. First of all, it's important to understand that a confidence interval is literally just a range of values that are plotted on a number line. First, we have our lower limit, then we have our upper limit. Halfway between the lower and upper limit is what's called the point estimate. The distance from the lower limit to the point estimate is called the margin of error. This distance is the same as the distance from the point estimate to the upper limit, and that is also called the margin of error. Remember, the margin of error is always positive. If you're going to be using manual calculations, the manual calculations will help you find the margin of error. Once you find the margin of error, you will then have to calculate the lower limit by subtracting the margin of error from the point estimate, and you'll have to calculate the upper limit by adding the margin of error to the point estimate. Make sure you have these in your notes. If instead of using manual calculations, you are using StatCrunch will be giving you the lower and upper limits. You will have to subtract these and then divide by 2 to find your margin of error. This is also an important equation to have in your notes. How to construct a confidence interval. First of all, you need to decide what type of data you are working with. If you have categorical or qualitative data, then you collect data of sample size n and calculate the sample proportion p hat to estimate the population proportion p. Remember, we are working with inferential statistics. That means we take a sample from our population in order to make inferences about the population as a whole. We must sample less than 10% of the population if sampling without replacement. Your textbook author Sullivan uses a more stringent requirement and says that we must sample less than 5% of the overall population in order to consider our samples independent if we are sampling without replacement. When we construct confidence intervals, we are estimating the population proportion using data from the sample. Let's see what a confidence interval looks like with categorical data. In the center is the point estimate, and for categorical data, that is the sample proportion, which is represented by the symbol p hat. The lower limit can be calculated by subtracting the margin of error e from the point estimate p hat. Likewise, the upper limit can be calculated by adding the margin of error to the sample proportion p hat. The distance from the lower limit to the point estimate p hat is called the margin of error, and that is the same distance from the point estimate to the upper limit. If you're going to use manual calculations, this is the equation that you would use. E equals z of alpha over 2 times the square root of p hat q hat over n. You might notice that there are a few symbols here that are new. One is z of alpha over 2, and I have a whole video that explains how to calculate that and what it means. The other one is q hat. Quite simply, q hat is 1 minus p hat. If you are using StatCrunch or technology to calculate your confidence interval, you will need this equation right here. Technology will give you the lower and upper limit of your confidence interval, and then to find the margin of error, you will need to find the total distance from the lower limit to the upper limit, and then divide that by 2 to find the margin of error. Remember, the margin of error is always positive. The relationship between xn and p hat. Before we go any further, let's discuss these relationships here. X represents the number of successes. The sample size, or the number of trials, is n, and the sample proportion is p hat. The sample proportion p hat is equal to the number of successes x divided by the sample size. We can rearrange this equation by multiplying both sides by n, the sample size, and when we do that, we find that the number of successes x is equal to the sample size n times p hat, the sample proportion. One other equation to keep in mind and have in your notes is that q hat, the proportion of failures, is equal to 1 minus p hat. Let's use this example to illustrate the relationship between x, n, and p hat. Suppose 7 marbles are chosen from a jar of marbles. 1, 2, 3, 4, 5, 6, 7. The sample size is 7, so that means n is equal to 7. Then we define success as picking a yellow marble and failure as any other color. The number of successes then is the number of yellow marbles. There are 1, 2, 3 yellow marbles, so x, the number of successes, would be 3. Since we have x and n, we can calculate our sample proportion p hat. To do this, we simply divide the number of successes x by the total number of marbles, which is 7 in our sample, so we get 3 out of 7, or about 0.43. Let's look at a similar example in which we're given slightly different pieces of information. So suppose 6 marbles are chosen from a jar of marbles, so this time our sample size is 6, or n equals 6. Now, again, so we'll define success as picking a yellow marble and failure as any other color. This time, we're not given the number of successes. Instead, we're given p hat. In other words, we're told that 50% of the sample is yellow. So how can we use n and p hat to calculate the number of successes? Well, quite simply, all we have to do is to find 50% of 6. And of, remember, means multiply. So 6 times 0.5 is 3. Now let's talk about the assumptions and conditions that must be met in order to construct a confidence interval with categorical data. The first thing is that all conditions of the binomial must be met. To review, those conditions are as follows. There must be 2 possible outcomes defined as success and failure. The probability of success, p, must be constant. Remember, p is the population proportion. Each trial must be independent from the other trials. And lastly, there must be a fixed number of trials. These are the 4 requirements of the binomial distribution, and all 4 must be met in order to construct a confidence interval for categorical data. In addition to the conditions of the binomial being met, we also have a requirement that there must be at least 10 successes and 10 failures in our sample. The way we express this is that n, our sample size, times p hat, our sample proportion, is greater than 10, or n times q hat, the number of failures, is greater than 10. However, your textbook publisher Sullivan changes this requirement a bit by using a more stringent inequality. Specifically, he says that n times p hat times q hat must be greater than 10. We will be using this last inequality since your homework comes from the textbook problems. To summarize, there are therefore 5 conditions that must be met, the 4 conditions of the binomial plus that last inequality that we saw. So before we can construct a confidence interval, we must make sure that our outcomes are 2, success and failure, that the probability of success, p, is constant, that each trial is independent from every other trial, that there are a fixed number of trials, and lastly, we must establish that n times p hat times q hat is more than 10. What are the steps to constructing a confidence interval for categorical data? The first thing we do is to check all the assumptions and conditions that we just mentioned. Next, we will identify our variables. And then for our third step, we will either enter our data into StatCrunch or we will calculate values manually. Once we've done that, we can construct our confidence interval, identifying and labeling the lower and upper limits, the point estimate, and the margin of error. Last but not least, we write a sentence to summarize our confidence interval. You should now be able to answer the following questions. What are the 4 main parts of a confidence interval? What assumptions and conditions must be met to create a confidence interval for categorical or qualitative data? And lastly, what are the 5 steps of constructing a confidence interval? Please watch my next videos to see specific examples of constructing confidence intervals with categorical data.